whatever it is that they're saying is, the manufacturer claims this, the consumer claims this. That's regardless if it's HO or HA. Then you find if it's got the equal sign, it's the HO. Without the equal sign, the HA. When you sketch, the tail follows the HA. So they specify your level of significance, and they usually give you that, usually 0.01, 0.05, or 0.10. You determine your Z-score test. From that, you look at your Z-score, that's your p-val, your area under your curve. So if it's a left-hand test, we use the left side. If it's a right-tail test, we use 1 minus that. If it's a two-tail test, we look up 1, we multiply it by 2. You have 2 chances to hit it. Then by that, we make a decision. We test the p-val against your level of significance. If your p-val is less than or equal to your level of significance, we reject the null. If not, we fail to reject the null. Those are the only 2 decisions we can make. Reject the null or fail to reject the null. Then we use that chart and we interpret your decision based on that chart. So let's try another one together. We did a couple of them Friday, which I think kind of helps when we finally get these all together. Okay, so I'm on page 350. In an advertisement, a pizza shop claims, here's your pizza shop, that its mean delivery time is less than 30 minutes. Fill your information out. A random selection, here's your sample. You always use your sample to challenge your population. So a random sample of 36 delivery times. We did this one?
Yeah, we did.
Oh, okay. All right. And we don't have to do this one. Perfect. Let's go to 5. Did we do 5? Okay. Okay, you think that the average franchise investment shown in the graph is incorrect. So if you look at the graph on page 351, they give you percentages here of investment franchises. So now, you think it's incorrect. So you randomly select. If you think it's incorrect, you're challenging what's there. This is not the claim. The claim is what's there. You're challenging this. This is your sample. So you're challenging this by taking a sample of your own things. And you determine the necessary investment for each. The sample mean investment. There's your sample mean. With the standard deviation, is there enough, oh, okay, I guess they're using this claim. Is there enough evidence to support your claim? If they use the word support, is your claim going to be an HO or an HA? HA. If you use a chart, when your claim is your HA, you use the word support. If your claim is your HO, you use the word reject. So that kind of helps you line this up. So let's write yours. You determined that the sample mean, what's the next list? So you say that it is not this. All right, you're saying that it's not. So their sample mean shows what? Okay, good. So their sample mean shows this. 60? Okay, you're challenging that. So you find all your information and you say that you think yours is this. If you think yours is this and theirs is this, what is your claim?
It is not.
Good. It is not. Here's your claim. It is not equal to this. This is your claim. This one was a little tricky because it's kind of a little sticky on the wording. So you're challenging their statement that their mean investment is $143,260. You're saying it is not. And your data is going to prove that it is not. Now, even though they look like they're not, you got to watch your standard deviation. It's your standard deviation that has an effect on this. So it's not as easy as looking at it to say, oh yeah, it's definitely not. You got to watch your standard deviation. So we're going to test your claim based on this. Now, this is your claim, this is your HA. And we said, yeah, when they use the word support, that comes from your HA. So right away, you should see everything starting to line up. This is your null, HO. You test by, you make your chart by your HA. You got a two-tailed test. So remember, whatever we find in your Z, we're going to say double this. Because we don't care if it's less than that or equal to that or greater than that. We just want it not to be the same as that. Okay? We don't want it to be equal to. Now, you go find your Z-score. Test with your Z. When you find one Z, the other one is the positive. They have to be the same. You still have symmetry. Okay? So find your Z. So x minus the mean, again, you're working with the sample. So you have to take the square root, you have to do your standard deviation over the square root of n.
How do you know it's a double test, like a two-tail?
Because the not equal is a two-tail.
Okay.
In other words, I don't want this to be equal to. I don't care if it's less than, I don't care if it's greater than. I just don't want it to be equal to. So therefore, your equal to is in the middle, and your less than and greater than are on the side. It could be either one of those. So it kind of gives you a double chance. Otherwise, an equal is hard to get because you're just getting an exact number. So now, you plug this in, your mean, minus the population mean, over your standard deviation, divided by the square root of n. And you come up with a z-score. Right, now, your z-score in this case could be positive or negative because it's symmetric. So we look up this. This is your 1.51. This is negative 1.51. This is your 1.51. We look up this guy. And all we have to do is multiply that by 2. Because we got two chances, two tails to do this. So we look it up and we find it to be 0.0655. That's your p-val for this. And we multiply it by 2 because we want to take this into account as well. So on a not equal, you get to multiply them. You get a little bit better chance. So 0.1310. This is your final p-val. Now, once we finish all this, we actually have to test against your level of significance. So we're testing your p-val against your level of significance. Your p-val is this, and your level of significance is 0.05. Easiest way, fill it with zeros. Make it the same length. And then drop the decimal and compare the numbers. So is 1,310 greater than or less than 500? Greater than. So what's your decision? Fail to reject HO. Okay? You fail to reject a null. We can either fail to reject a null or reject a null.
So HO is a null.
HO is a null. And HA is your alternative. Now, sometimes in some books they use H1, H2. H1 is your primary, H2 is your secondary. Our book uses HO, HA, and a lot of books use HO, H1. So they're the null and one more. So it depends which books you're looking at and how they have it set up. All right. So now you're going to follow your chart. This is what I want you to think to yourself, though. If we fail to reject this, can we agree with this claim? If we fail to reject this statement,
How are we going to reject
the null, HL. So if we fail to reject this, in other words, we have to take that one, right? If we fail to reject it,
our claim is null?
so we can't agree with our claim. So now, when you follow your chart, you go down, HA is your claim, you fail to reject your null, and you have to use those words. There is not enough evidence to support the claim that the mean is different from this guy. The mean is different from 143,260. That's your claim. The mean is different. It's not equal to that. So, in other words, in your head, you're saying, if I keep this, this can't be true. If I don't keep this, then this is true. That's how you try to logic it out. But then go to the chart and use the words from your chart. Good? All right. Try it yourself, number 5. Here, before you look at your claim, before you see what your claim is, go to your sample information first. Because once you get your sample information, you don't confuse it with your claim. So now, here's our standard deviation of 15. This came from your sample. So none of this information can be used in your claim. Your level of significance is 0.01. Is there enough evidence to doubt the distributor's reported average? You're challenging this average. What was his average? 150. There is the claim. This is the claim. Then you're doubting this claim. So you challenge this with your sample. So the opposite is, it is not equal to. Is the claim the HO or the HA? HO. The HA doesn't have the equal sign. The HO has the equal sign. Okay, all of this is extremely important. Now,
Isn't it supposed to be? You said the average is not accurate.
Yeah,
You
so
suspect the average is
the
not.
claim is that.
It says you suspect this average is not accurate.
right, you suspect it's not. Yeah.
So what does that
So
be your
his-
claim?
Okay, so now, but the problem is this. His claim is that it's 150. You suspect, you challenge his claim. This is the opposite of what they did before. What threw this off is, do you doubt this? They should have said, do you support, do you reject this? They should have said, do you reject his average? And then you would have seen what his claim is. If they would have said support or reject, you would see it's actually the opposite of the one before. And that's why the wording is always very, very tricky. His claim is this, that it's equal to this. You're saying, okay, it's not equal to this. We did the same thing before, but the claim was different. This claim is now his claim. This is your findings. Your findings show that's not the case. So now I'm going to challenge your claim. It is totally the opposite of the one we just did.
So we're trying to reject the claim.
We want to reject or fail to reject. Yes, we want to reject. We doubt it. We reject it. We're not supporting. If we didn't doubt it, wouldn't we support it? Right? So instead of the word doubt, can I plug in the word reject? Right? In other words, they use the word doubt instead of reject. If we agree, wouldn't we support? Right? See what I'm saying? So does this fit now? Like, could I put the word support in here for doubt? Mm-mm. I would put the word reject, which means the claim has to be the HO. The wording is always the trickiest part. That's why I said pull out your sample information first. Pull out your sample and then you see where you go from there. And usually somewhere they give you like a nice hint or two. Most of the words they'll use is reject or support. Or they'll say agree. If you agree, do you reject or do you support? If you agree with something, you support. If you disagree with somebody, you reject. So you got to play with the words. So if you doubt something, you're not going to support it, right? You're going to reject it. So the words are a little trickier. So here's your two-tailed test. You're just saying it's not equal to. I don't care if it's less than. I don't care if it's greater than. I just don't want it to be equal to. So a two-tailed test means you have two options, and you're just going to either add them or multiply one of them by 2. So you take your z-score, and here's your mean. So x is your 130, is your 130, 143? 143.
Minus 150.
Good. Over your standard deviation, divided by 35?
Yeah.
35. So what's your z-score?
2.73. Negative 2.73.
Okay, now, that's here. If we look up this z-score, we're going to multiply it by 2. Because we've got double the chance to do this. So, 0.0029 multiplied by 2. Okay? This is your p-value. Question? No? Okay. So now, your p-value compared to your level of significance. 0.0029 0.0058, and here's your level of significance. 0.01. Fill it with zeros. Now, easier test is 58 less than 100 or greater than 100? Less than. So if it's less than or equal to, what is your decision? Good. This is the decision. You did all of this to come to this decision. Now, you're going to follow your chart. But first, we're going to go back to this. If we reject HO, so we reject this, that means we take ours, right? That means we agree with the fact that it's not equal to. That means our sample showed that there was a problem with his claim. So we go to our chart, we say when your claim is your HO, and you reject HO, there is not enough, well, there is enough evidence to reject the claim that the mean average of sales per day is 150. That's how you have to word your interpretation. You're rejecting HO and go to your chart. There is enough evidence, and HO uses the word reject, to reject the claim that the mean average is equal to 150 sales per day. You do all this work to present this to whoever it is asked you to challenge this. And that's the statement you give them back. Okay? Now, you have your calculator handy? We're going to put this in your calculator. Let me see if I can find that. These are really nice in your calculator, and you probably hit this by accident because it's the z-test one. And remember I said if you knew that, if you were looking up an interval or whatever you were doing, if it had a tail, you had the wrong one. This is the case where the tail is. So if we pull this up, I can show you on your calculator where this goes. It doesn't, you still have to make your claim, you still have to draw your graph, you still have to figure out which tail it is, but you don't have to test the z-score, you don't have to look it up in the table, it will come back with your p-val. Okay, good, that wasn't so bad. So, if you have a calculator, or if not, if you watch up here, you hit stat, you go to test, and you're the very first one, z-test. You have a z-score because we're using a large sample greater than 30. We're testing the hypothesis. Now, when you do this, here's your population mean. Our population mean was 150. Your standard deviation is coming from your sample. It says population, but because the mean is greater than 30, the sample is the same as the population. So your sample standard deviation is 15. Your sample mean was 135. And your N, oh, where did I get 143? 143. And your sample N is 35, right? Did I get the standard deviation? Now, watch. Here's your tails. This tail, this is the most important part. This tail points to where your tail is when you sketch this. So, if it's a less than, a left tail test, it's pointing to the left. If it's a greater than, a right tail test, it's pointing to the right. If it's a not equal, it says not equal. So we're going to come here, hit the not equal, and come down to calculate. Now, here's your p-val, so bless you. Here's your z-score that you found, and there's your p-val, so bless you. Not equal. Much easier. But it also, and I wrote over it, but it also takes your p-val and it doubles it for you. So when you do this, That's your final p-val, whatever they give you. If they needed to subtract it from 1, they did. If they needed to multiply it by 2, they did. So that's your p-val that you're now going to test against your level of significance. It helps you bypass your z-score, looking it up on your table, multiplying it by 2. But you still have to write your claim, your HO, your HA. You still have to do your tail test because you need to know your tail test before you can put this in. And the arrow follows your tail. If it's a less than, it's pointing to the left. If it's a greater than, it's pointing to the right. If it's a not equal, it says not equal. So those are the tail tests that you have to follow. This also is nice because it gives you your z-score as well. So again, this is a nice little test to be able to use this on your calculator and to make a decision. Questions? No? Okay. Understand them? Good. Here's your test again. Your z-test, your data. This is your population. This comes from your claim. This is your claim information. This right here is from your sample. This is your test stuff. This is the tail. If the tail happens to be a left tail test, that's this guy. It points to the left. If the tail was a right tail test, that's this one. The tail points to the right. Because technically you're saying this. You're saying your mean was not equal to 150. This is your U sub 0. Or your mean is greater than 150. This is your U sub 0. So it's saying your mean is greater than 150. That's your U sub 0. That's your value at your mean. But all you have to do is just follow your tail on that one. It's a nice test. And it's the first one there. So that's even nicer. Now, I'm going to stop at your reject region because I don't really want to go through this part. But I'm going to give you some to do for homework. And I would like you to do this at home. Homework at home. A novel idea. This is because what it does is it actually pulls together every single thing that we've